in section 4.3, we'll learn another way to solve system of linear equations, and that's by using the addition method. Now, with the addition method, what we want to try to get is either the x's to have opposite coefficients or the y's to have opposite coefficients. Because if you can get x or y to have opposite coefficients, when you add, it's called the addition method, when you add vertically, if they have opposite coefficients, they'll cancel. So here I have the system. Let's look at classroom example 1. If I have x plus y equals 13 and x minus y equals 5, x plus y equals 13 and x minus y equals 5. Now what needs to happen for the addition method is the x's have to line up, the y's have to line up, and on the right hand side of the equal sign is where you have your constants. If I just add these vertically, x plus x is 2x. Positive y and negative y cancel. And then 13 plus 5 is 18. So now I have 2x equals 18. So I can solve for x by just dividing both sides by 2. So I used the fact that this was a positive 1y and this is a negative 1y. The coefficients for the y's were opposites. So if x equals 9, I go to either one of my equations and substitute in a 9. If x plus y equals 13, that must be 9 plus y equals 13. So subtract 9 from both sides, and you get y equals 4. And the shorthand way to write x is 9, y is 4 is the ordered pair 9, 4. So we've already tried x plus y equals 13. Just to check your work, look at the other equation. Substitute 9 in for x and 4 in for y. Does 5 equal 5? Yep, it checks. So we're very happy to use the addition method, especially when the system already has equations where the x or the y have opposite coefficients. So why don't you go ahead and try practice 1. Now, looking at this system, for example 2, 2x minus y equals 6 and negative x plus 4y equals 17, neither the x's nor the y's are the opposites of each other. But remember, one of our rules for equations is as long as you do the same operation to the both sides of the equal sign, you've got an equivalent equation. So here I have a positive 2x. If I were to multiply this whole equation by 2, then I'd have a negative 2x, and I'd have a positive 2x and a negative 2x, and I'd be able to use addition. So that's what I'm going to do. I'm going to rewrite this equation. I'll just put a line here so you know I'm rewriting this. 2x minus y equals negative 6. And let's multiply this whole equation by 2. Negative 2x plus 8y equals 34. Don't forget to multiply both sides of the equation by 2. It's a very common mistake to forget to multiply both sides of the equation by 2. Now when I add vertically, my x's will cancel. Positive 8 and negative 1 is 7. Y equals, and 34 minus 6, or negative 6 plus 34, is 28. So dividing both sides by 7, I get y is 4. So I'm halfway home. I have the value for y. And so what you're going to do now is you go to either of the equations and substitute 4 in for y. So let's go ahead and use this one. 2x minus, put in your 4 for y. So we'll add 4 to both sides, and we get 2x equals -2, and divide both sides by 2. We get x equals -1. So my solution is -1, 4. And remember, you are always going to want to check your answer in both equations to make sure -1, 4 makes both equations true. You'll check to find your own, if you've made a mistake. All right, so why don't you try practice 2? We're going to move on to example 3, and let's solve this using addition. All right, so here I have a 1x and here I have a -3x. You know what, if I multiply this whole first equation by 3, we have x minus 3y equals -2, and -3x plus 9y equals 5. If I multiply this whole first equation by 3, I'll get opposite coefficients for my x's. Distribute the 3. 3x minus 9y equals -6. And then I had -3x plus 9y equals 5. And now I'm going to add vertically. Well, here the x's cancel and the y's cancel, so I'm left with 0 equals -1. When will 0 equal -1? Never. Contradiction. Contradiction means no solution to the system. There's no xy value that will ever make my original 2 equations in my system true. All right, so why don't you try practice 3? Moving on to class from example 4 here. I have a 2x and a -4x. You know what? If I multiply this whole equation by 2, I'll get a 4x and a -4x, and that will work. So 2x plus 5y equals 1, and -4x minus 10y is going to equal -2. And I've decided I'm going to multiply this whole first equation by 2. Why? So I can get my x's to cancel. Distribute the 2. 2 times 2x is 4x. 2 times 5y is 10y. 2 times 1 is 2. And then write your original equation, the second equation. So when I add vertically, my x's cancel and my y's cancel, so I'm left with 0. And 2 minus 2 is also 0. All right, when will 0 equal 0? Always. This is always true. These are actually the exact same line, and there are an infinite number of solutions. Every point on the line is a point actually on both lines because they're the exact same line. All right, you're going to try practice 4.